Hello, hello. Am I audible? Can anyone confirm in the chat if I am audible?
Yes.
And is my screen visible?
Yeah.
Okay, thank you. So, good evening, everyone. Welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. So, this is the third live session. In this live session, so my name is Owen Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this live session, we will discuss some practice problems on week 3 topics. So in week 3, the topics are linear classification, logistic regression, and LDA. So these are the three topics that have been covered in this course in week 3. So we will discuss some practice problems on these topics, and also I will also try to clear your doubts if you have any. So please feel free to ask me your questions and queries regarding this week 3 topics. So Charan Yashu says, please give me the information about. So exam registration last date, so you can ask that in the discussion forum. So we don't have any information about that. So that is handled by the NPTEL office, exam registration and everything. So you can directly contact the NPTEL, or you can ask in the discussion forum of this course. So they will be able to answer your question. So we can start the practice problem session part of this session. So this is the first question. Which of the following is false about a logistic regression based classifier? So you have to find out which of these are false about logistic regression. So the first option is the logistic regression is non-linear in weights. Second option is the logistic function is linear in the weights. Third option is the decision boundary is non-linear in the weights, and the fourth option is decision boundary is linear in the weights. So which of these four options is or are false about logistic regression? So there might be multiple correct answers in this question. So you have to find out all possible options here. You can write your answers in the chat. So I have not received any answer in the chat yet. So has anyone found the answer? Srijan has written A for sure, not sure about C and C or D. So you have to find out which of the following is false about a logistic regression based classifier, not right. So which of these are false about logistic regression. Kameswar Panda has written B and C. Okay. Any other answers? Anyone else? Has anyone else find the answer? So I've got B and C, and Satyam Gupta has written A. So I've got two answers, B and C, and these are the two answers that I'm getting from the chat so far. So the correct answers here are B and C. These are the two correct options. So these two statements are false about logistic regression. So the first option is the logistic function is non-linear in the weights. So this is certainly true that logistic function is non-linear, because logistic function looks like this, it is power minus x. So and this x will contain the weights and the multiplication of the weights and the feature vector x. So this function is certainly non-linear. So first option is correct, so that is not false about logistic regression. Then second option is the logistic function is linear in the weights, so it is non-linear in the weights, as I have already written. So the option B is false about logistic regression. This is one of the correct options. And option C is the decision boundary is non-linear in the weights. So if you understand the logistic regression, so if these are the positive points and these are the negative points, so two classes, and so two sets of points, so classifier or the decision boundary is always linear like this. So decision boundary is linear. That means option C is false, that decision boundary is non-linear in the weights. So the decision boundary or the classifier is always a straight line or linear function. So option C is also false about logistic regression. So that's why option B and D, these are the two correct answers here. These are the two statements that are false about logistic regression. So this is why these two would be the correct answer. Is there any questions or doubts in this problem? Okay, so we can move on to the second question. So this is question 2. Consider the case where two classes follow Gaussian distribution, which is a normal distribution, which are centered at 3, 9 and minus 3, 3 and have identity covariance matrix. So there are two classes. First class is centered at 3, 9, second class is centered at minus 3, 3, and both the classes have identity covariance matrix. So basically shape would be circular for both the classes. Which of the following is the separating decision boundary using LDA, assuming the priors to be equal? So basically you have to find out what LDA would output as the decision boundary. If the points are the first class is centered at 3, 9 and the second class is centered at minus 3, 3. So Hetal has written option C, which is x plus y equals 6. Okay. Anyone else? So Vamshi Verma has asked, which is the topics. So Vamshi, you can ask this question in the discussion forum. The regular TAs and the instructor of this course would be able to answer your questions, which are the topics that would be required. So it's better if you ask in the discussion forum. So there the regular TAs answer the queries or questions regularly. So it would be better if you ask in the discussion forum. So has anyone else computed the answer for question 2? Srinivasa Rao has said C. Saneli Keho has also written C. Okay, so I've got 3 answers in the chat. All the answers are option C. Kameshwar Panda has written option D. Okay, both B and C. So in this question, if we simply plot the means of the two classes, so here we will get 3,9, and here we will get minus 3,3. So these are the two centers of the two Gaussian distributions, and both the classes follow identity covariance matrix. So if we join these two centers, we get this straight line. So as both the classes are following identity covariance matrix, that means the decision boundary would be perpendicular to the 2 points, 2 centers, and it would pass through the center of this line segment, midpoint of this line segment. Sorry. So we have to find out the midpoint of this line segment, and the decision boundary would be perpendicular to this line segment, and it would pass through the midpoint of this line segment. So this is the decision boundary, this one. So what would be this midpoint? You have to first find out this midpoint. So the two centers are given 3,9 and minus 3,3. So if you compute the midpoint, it would be 0,6. So it's fairly easy to find out the midpoint of a line segment. You just take the average of the x coordinates and take the average of the y coordinates. So 3 and minus 3 are the x coordinates, so average is 0, and y coordinates are 9 and 3, so average is 6. So 0,6 is the midpoint of this line segment, and now you have to find out what would be the slope of this decision boundary. So the slope of this decision boundary would be perpendicular to the slope of this joining straight line. So the slope of this line segment is 9 minus 3 divided by 3 minus minus 3. So it is 6 by 6, so 1. So the slope of this line segment joining these two centers is 1. So that means slope of this decision boundary, which is perpendicular to that line segment, would be minus 1. So slope of this straight line would be minus 1. So we have got this slope, and we also know the midpoint 0,6 through which the straight line would pass. So now it's easy. So straight line equation of a straight line is y equals mx plus c, and m is minus 1, so we can replace it, y equals minus x plus c. And we know one point on this straight line, which is this 0,6. So if we put this point into this, so it would be 6 equals 0 plus c, so c equals 6. So the equation would be y equals minus x plus 6 or x plus y equals 6. So this is the equation of the decision boundary, x plus y equals 6. So that is option C. So most of you have written option C, but some of you have also written option D. I don't know how you are calculating that, but option D says both B and C, but option B is not completely correct here, because though x plus y equals 3 might separate these two classes, but LDA would always, as the classes have identity covariance matrix, so the decision boundary would pass through the center of the straight joining straight line segment, and it would be perpendicular to the line segment joining the two centers. So using that, we will only get x plus y equals 6. So is there any doubt in this question? So we can move on to question 3. Logit transformation of probability of x equals 1 for given data S is this. Then what is the logit transformation of probability of x equals 1? So logit transformation of a probability value p is p divided by 1 minus p. So this is the logit transformation of a probability value. So here p is this probability of x equals 1, and the data set is, the whole data set is s equals this 0 1 1 0 1 0. So this is the whole data set. So you have to first find out the probability of x equals 1, and then you have to compute the logit transformation for that probability value. So Satyam Gupta has written B, Harshal Kolte has written B. So both the answers are B in the chat. Okay. Any other answers? Durga Prasad has also written B. Aditya Chauhan has written C. So Three answers are B and one answer is C from the chat. Hetal is saying D. Okay, some of you are saying B, some of you are also saying C, D. Kameshwar Panda has written B. Okay, so most of you were saying B, but some other options are also there in the chat. So in this question, first you have to find out probability of x equals 1, and this is the whole data set. This, so from this data set you have to find out what is the probability of x equals to 1. So there are 1, 2, 3, 4 ones are there out of total 7 points, so it would be 4 by 7. 4 by 7 is the probability of x equals to 1. And now you have to find out the logit of this. Basically, sorry, you have to find out the logit of probability of x equals 1. So this is what you have to find out. Logit of this is 4 by 7 divided by 1 minus 4 by 7. So this is 4 by 7 divided by 3 by 7, which is 4 by 3. So 4 by 3 is the answer, option B. So most of you have written option B in the chat. So this is how you have to calculate logit transformation here. So first you have to find out the probability value from the dataset, and then you have to use this formula for logit transformation, P divided by 1 minus P. So if you compute the answer, it would come as 4 by 3. So option B, 4 by 3 is the correct answer. Now moving on to question 4. The output of binary class logistic regression lies in this range. 4 options. First option is minus infinity to infinity. Second option is minus 1 to 1. Third option is 0 to 1. And the fourth option is minus infinity to 0. So what is the range of the output of the binary class logistic regression? So you can write your answers in the chat. So Aditya Chauhan has written A, Avinash has written B. Okay, so I've got 2 different answers in the chat. Kameshwar Panda has written A, Harshal has written B, Durga Prasad has written A. So many of you were saying A, many of you were saying B. Satyam Gupta has written C. Okay, so A, B, C, these are the different answers I am getting from the chat. Any other answers? Anyone else? In logistic regression, so the output comes from the logistic function or the sigmoid function, so which looks like this. F of z equals 1 divided by 1 plus e to the power minus z. So this is the logistic function or the sigmoid function. The output comes from this function, and if you plot this function, it will be something like this. So this is 1 and this is 0. So the output is output of the sigmoid function is between 0 to 1. So it's a continuous function. So at the value varies from 0 to 1 for this function, and the output of the logistic regression is the output of the sigmoid function that we get. So option C is the correct answer, 0 to 1. Yeah, so I had some technical problems, so that's why I had to reshare my screen. So Aditya Chauhan has written, can you explain? Okay, so in logistic regression, what we do is that so in logistic regression, these are the input layers. From that we through the weights w1 w2, so these are x1 x2 like this, we add all those things and then apply the sigmoid function, and that here we get the output. So it would the output looks like sigmoid of w transpose x. If you go through the video lecture, so it would look like this. The sigmoid is this sigmoid function, so it would be 1 divided by 1 plus e to the power minus w transpose x. W is the vector, weight vector, and x is the input feature vector. So this is the output that you get from a binary class logistic regression, where there are only two classes, 0 and 1. So this the value of this function ranges from 0 to 1. So this is the graph. So that's why the value ranges from 0 to 1. So the output of the logistic regression would also lie between 0 to 1. So this is how you can calculate it. Is there any other doubt in this question? Question 5. So logistic regression is robust to outliers. Why? So you have to answer why logistic regression is robust to outliers. There are 4 options. First option is the squashing of output values between 0 to 1 dampens the effect of the outliers. Option B is linear models are robust to outliers. Option C is the parameters in logistic regression tend to take small values due to the nature of the problem setting, and hence outliers get translated to the same range of the other samples. And option D is the given statement is false. That means logistic regression is not robust to outliers. Option D is that. So why is logistic regression robust to outliers? Hital is saying option B. Vavik is saying option C. Arshal is also saying option C. Avinash is also saying option C. So most of you are saying option C. Satyam is saying option A. Srijan is also saying option A. A, B, C. These are the three options that I am getting as answers from the chat. So the correct answer here is option A. The squashing of the output values between 0 to 1 dampens the effect of the outliers. So this is the actual correct answer. So outliers are problematic because very few points which are outliers can drastically change the output of the model. But in case of logistic regression, the output value is between 0 to 1, so it cannot drastically change the value too much. Because all the output values are squashed between 0 to 1, so it reduces the effects of the outliers. But option B, which is linear models are robust to outliers, we cannot generalize it like that linear models are robust to outliers. It depends on what kind of loss functions we are using, or what kind of regularizer we are using. So we cannot generalize it like that, because it is a linear model, it is robust to outliers. We cannot say that. And option C is the parameters in logistic regression tend to take small values due to the nature of the problem setting, and hence the outliers get translated to the same range as other samples. So this is also not true, that parameters of the logistic regressions tend to take small values due to the nature of the problem setting. Output would be between 0 to 1, that value is small, but that doesn't mean that parameters should also be small. Parameters can be anything from minus infinity to infinity. So parameters can have very high values, but the output comes from the sigmoid function. That's why the output always ranges from 0 to 1. So parameters can have any value between minus infinity to infinity. So this is not correct. And option D is obviously not correct, because logistic regression is robust to outliers. So option D is not correct. So option A is the only correct answer here. Now we can move on to question 6. So we have two classes in our dataset with mean 0 and 1 and variance 2 and 3. So now you have to answer whether LDA may be able to classify them perfectly. LDA will definitely be able to classify them perfectly. LDA will definitely not be able to classify them perfectly. And last option is none of the above. So these are the means of the two classes, and these are the variances of the two classes. So now you have to answer whether LDA would be able to classify them or not, these two classes or not. So Aravind is saying option C. Option C is LDA will definitely not be able to classify them perfectly. Okay. Any other answer? region is saying option B. B is LDA will definitely be able to classify them perfectly. Okay. Pancham is also saying B. Jayas is saying B, Hital is saying B, Sanil is saying C, Harshal is saying C. So many of you are saying B and many of you are also saying C. Avinash is also saying C. Aditya Chauhan is saying D. Okay, none of the above. So to answer this question, you can plot the means and the variances. That would be then it would be easier to visualize and find the answer. So if this is 0 and this is 1, so these are the two means, 0 and 1, and two means of the two classes, and variances are 2 and 3. So we need to find out the standard deviation, which is root 2 and root 3. So root 2 is around 1.4 and root 3 is around 1.7. So that means and it is a Gaussian distribution, obviously, because we are applying LDA onto it. So that means the Gaussian distribution centered at 0 has a standard deviation of 1.4. That means it would be like this. Here is 1, and if it is 1.4, this point is 1.4. So it would be perfectly circular, not like this elliptical figure. So but it the Gaussian distribution of the first class, this is the Gaussian distribution of the first class, would look like this, and similarly the Gaussian distribution of the second class, which is centered at 1 and standard deviation is 1.7. So that means so it would be something like this, because 1.7 would obviously no, this would be, so this would be something like this. So because these standard deviation values are higher than the distance between the two means, that means some of the points are outside outside its own region. So that means some of the points of the first class are in the region of the second class, some of the points of the second class are in the region of the first class. That means we will not be able to perfectly classify them. So the two classes are overlapping basically. So that means LDA will not be able to perfectly classify them. So that's why option B will be the correct answer.
So you are saying LD will be able to classify?
Oh no, sorry, not B. No, I'm saying LD will not be able to classify because the two classes are overlapping. Because of the standard deviation values are higher than the distance between the two means. So obviously the two classes are overlapping. So it will not be able to classify.
I must say C because in LE anyway we were expecting that the Gaussian variation will be same. So that is why I was seeing C, answer C when I was replying to your question. I didn't visualize in this way.
Yeah. So. Yes, some other ways can also be there, so to answer that, but because mean and variance values are given, so we can visualize it on a 2D plane, and we can see that variance values are too high, that means points are very much scattered, so the classes are overlapping obviously, so that means it will not be able to perfectly classify.
And also LD is expecting the variance to be same, right? For all the
uh,
same.
no, I mean these are intra-class variances. So variance of this class is 2 and variance of this class is 3.
Correct. So the intra-class Gaussian variance. Oh, okay. Okay.
It is not the inter-class variance, that is assumed to be same for all the classes, but these are intra-class variance, so variance of the points only in that class, so that's why there are two different variance values.
Sorry for this. But from question, how you can confirm that it is actually intra-class variance and not inter? I mean, because
I mean, for the two classes, it is given that for the two classes, mean and variance are given. So the 2 and 3,
for one class it is two and another
another
class
class
it
it
is
is 3. Yes,
in that way also you can
yes, yes.
just I mean because I am also getting confused. That's why I am just asking again and again. Sorry.
Yeah, no, so the mean values or variance values are for two different classes. So there are two variance values given for two classes. That means these are intra-class variances. So variance of all the points within that class only. Um, so and in LDA the inter-class variance is also used. That is same for all the classes. But in this case, it is variance of only one class. So 2 is the variance of the first class, 3 is the variance of the second class. So Kameshwar Panda has written, if two classes have the same mean but different variance, then what will happen? Now, I mean same mean, that means the points are exactly overlapping. Same means that means all the points are overlapping. Almost all the points are, both the classes are overlapping. So obviously, if the means are same, you can never classify those two classes using LD or any other linear classifier. I think they are the same class if it's the same mean. No, I mean for two different classes the mean might be same, but it will not be the LDO will not be able to classify them. So it might happen that the mean values are same, but the linear classifiers would never be able to classify because all the points are in the same region. So and the classes are completely overlapping. So in that case, it would never be able to classify. So
Sorry. I mean, how you the Gaussian distribution? I mean, it's not normal bell curve, and it is actually you told that it's actually going to be circular. I still didn't.
so even if we consider one dimensional data, we can also consider 0 and 1. So even in case of one dimensional data, the standard deviation of the first class is first class is root 2, which is 1.4. So that means points are scattered from this minus 1.4 to here up to 1.4 at least, because standard deviation is 1.4. That means at least 1 point would be in this plus sigma minus sigma region, plus this minus 1.4 to 1.4, isn't it?
Yes.
So
Why you are not writing that as a bell curve? I mean, a normal bell curve, I mean, normal standard deviation curve. Instead, you are actually plotted that as a circular. So that's why.
no, I mean I plotted a circular. Also, you can use one dimensional data. It is basically one dimensional because the mean is given 0 and 1. So even if you visualize it as a one dimensional data, the same thing occurs, that the minus the points for the first class are scattered between minus 1.4 to 1.4, but the mean of the second class is 1. So that means some of the points are obviously overlapping. The two classes are not completely separate. So by visualizing the means and the position of the means and the variance values, we can find out whether the classes are overlapping or not. If the classes are not here in this case classes are overlapping, so it is not possible to perfectly classify those two classes. So now question 7, this is a similar question with different mean and variance values. So we have two classes in our data set with mean 0 and 5, variance 1 and 2. So these are the means and variance values for two different classes, and now again you have to find out whether LDA will be able to classify them perfectly or not. So I've got three answers in the chat. All three answers are option B. Arvind is saying option C. There is an overlap between the two classes. So this is what you have to find out, if there is a possibility of overlap or not. So that you have to find out using these mean values and variance values. Satyam is saying B.
The problem is that it is still having different variants. So that is why I am really not able to say that it is linear can be applied.
I mean, this is the variance values are only for one class to know whether the two classes are overlapping or not. Using this mean and variance values, we are trying to find out whether the classes are overlapping or not. If the classes are not at all overlapping, then it will be able to classify. If there is a possibility of overlapping, then it will not be able to perfectly classify. So this question is also a bit tricky. It's actually a little more little trickier than the previous one. For this question again we can visualize it on a we can use just one dimensional data here. 0 and 5, let's consider this 0 and 5, these are the two means, and variance is 1. That means standard deviation is also 1. So like this, so from -1 to 1, the points of first class are most of the points are scattered from between -1 to 1, -1 to +1, but that doesn't mean it cannot have any point here. So this can also be a point, this can also be a point belonging to the first class. This is just the standard deviation or the variance. And for 5 the variance is √2, which is 1.4. So most of the points would be between in this region, 5 minus 1.4 and 5 plus 1.4. But this is just the standard deviation. That means some of the points belonging to this second class might also be present here, here or here. Those are the outlier points, but those points might be there. So that's why, though the distance between the two means are much higher than the standard deviation or the variances of the two classes, LDA may be able to classify them perfectly, but it might not be also able to classify them perfectly if some outliers are present, because standard deviation doesn't mean points would only be present within that specified region of -1 to +1. It might be some point belonging to class 1 might also be present here. So in that case some of the points are overlapping, but most of them are not overlapping. So that's why LDA may be able to classify. So we cannot say it will be definitely able to classify or it will definitely not be able to classify. You cannot say that, but we can say that it may be able to classify them perfectly if such outlier points are not present. In that case, the standard deviation values are much lesser than the distance between the two means. These are the two means. So the answer is LDA may be able to classify them perfectly.
Okay, in that case, why in our original LDA mathematical interpretation, we are always saying that the variance cannot is expected to be same for all the Gaussian distribution. So that is still vague me.
No, I
And
mean in LDA, each class is considered as a Gaussian distribution. So,
yes, that,
these are positive classes. This is one Gaussian distribution. These are negative classes. This is another Gaussian distribution. So,
yes,
different
they are
classes.
going to be the same, right? Because this is the one class which has a mean 0 and another class which is having a mean 5.
Yes. Yeah. So mean is 0 here. Mean is 5. In this case, variance is 1. In this case, variance is 2. Because two different classes, we are given two different variance values.
Correct. So this is also perfectly same as, but again the problem for my worrying part is here the variance is different, but actually LD is expecting that it is need to be same. So that is what.
No, I mean here the variance values are given to visualize whether the classes are overlapping or not. So using the variance values, we can find out whether the classes may be overlapping or may not be overlapping. If there is a possibility of overlapping, then LDA will not be. LDA is a linear classifier, so it will not be able to classify if there is a possibility of overlapping. So these variance values we are only using to visualize whether the classes are overlapping or not. This is what we are using this variance for here.
Okay, still, I am not clear on that. I mean, just because the sigma k that is coming is sigma k half raised to square root of sigma k that is expected to be same. So that is what still worrying.
Yeah,
Okay,
yeah. In actual LDA formulation, the standard deviation we take for all the points. But here for different classes the different variance values are given so that we can visualize whether the classes are near to each other or they are far away from each other and whether they are overlapping or not. So for that reason the variance values are given for every class here.
okay.
So here the correct answer would be A. Srijan has asked, is there any case whether B is a solution? We'll definitely be able to classify. B is a solution. In that case, I mean, if we are, if we can confirm that the two classes would never overlap, in that case, we will be able to say that LDA will definitely be able to classify them perfectly. And in both the questions we cannot surely say whether the classes the two classes are completely separate from each other. There is a possibility of overlap in both the questions, so that's why in none of the questions option B is the correct answer. So Bhavik has written LDS formation. Yeah, this is right that these we consider the same variance in order to simplify the calculation for the LDA, but each class would have different variances, intra class variances, so that variance is calculated only using the points of that class only. So each class is considered a Gaussian distribution, so obviously each class would have its own mean and variance values. But in actual LDA formulation, we use a common variance or the covariance matrix we use to simplify the calculation there. So we can move on to question 8. So in general, which of the following classification methods is most resistant to gross outliers? So 4 options are there: quadratic discriminant analysis, QDA, linear regression, logistic regression, and linear discriminant analysis or LDA. So which of the following classification methods is most resistant to outliers? Sankarlal is saying logistic regression. Bhavik is saying option C, logistic regression. Okay. Bhaskar is saying LDA. Arshal is saying option C. Satyam is saying option C. So most of the answers are option C. So the correct answer here is option C, logistic regression. In one of the previous questions I already discussed that logistic regression is robust to outliers because of the sigmoid function, that is the actual output of the logistic regression. The output is between 0 to 1, which makes it robust to outliers. And other options like quadratic discriminant analysis, this uses the L2 norm or the squared error, and squared error is not robust to outliers at all. It gives much more importance to the points that are misclassified. So outliers are given high priority in that case. So QDA is not resistant to outliers. Same problem is there in LDA. The LDA also uses the L2 norm, and L2 norm gives much more priority to the misclassified points or the outliers. So the LDA is also not resistant to outliers, and linear regression also uses the square laws. So again it is also not robust to outliers. So only correct option is logistic regression because of its output which ranges from 0 to 1, and that's why it is resistant to the outliers. So option C is the correct answer. Question 9. In a binary classification scenario where x is the independent variable and y is the dependent variable, logistic regression assumes that the conditional distribution y given x so this conditional distribution y given x follows which distribution? Bernoulli distribution, binomial distribution, normal distribution, exponential distribution. So this y given x conditional distribution follows which distribution in case of logistic regression? Devendra Singh has written option A, which is Bernoulli distribution. Saneli has written C or D. Bhaskar has written option D. So the correct answer here is option A, Bernoulli distribution. So the dependent variable is binary, is the variable y given x. So this is obviously binary because there are only two options, y equals 1 given x and y equals 0 given x. So this variable is binary. So in case of binary, Bernoulli distribution is used. So in logistic regression, Bernoulli distribution is used for this conditional distribution. So the question 10, this is the last question of this session. So, we have seen methods like ridge and lasso to reduce variance among coefficients. These are the different two different regularizers, ridge regularizer and lasso regularizer. So we can use these methods to do feature selection also. Which one of them is more appropriate, ridge or lasso? So which of these two methods is more appropriate for feature selection? Srijan has written lasso. Bhaskar has written B, which is lasso. Anyone else? Harshal has written B. So correct answer is option B, lasso regularizer. So in ridge regularizer, L2 norm is used for regularization, and in lasso L1 norm is used, and it is taught in the previous week's lectures that the L1 norm is able to drive the coefficient values to 0, whereas ridge in most of the cases cannot do that. So ridge would be able to reduce the values of the coefficients or the parameters, but it would not be able to drive those values to 0, but lasso is able to do that. So as some of the coefficient values go down to 0 in case of lasso, those features are not used, so it acts as a feature selection method also. So that's why option B is used. So for feature selection we prefer to use lasso, since solving this optimization problem when using lasso will cause some of the coefficients to be exactly 0, whereas with ridge regression the magnitude of the coefficient will be reduced, but it won't go down to 0. So that's why ridge cannot be used for feature selection, but lasso can be used and it is appropriate for feature selection. So option B is the correct answer. Yeah, so these were the practice problems that I wanted to discuss today in this session. So now if you have any other questions or doubts, you can ask me. So is there any doubts or queries regarding any of the questions that I discussed today, or any other things in this week 3 topic?
Hey, again, is there any other video sessions? I mean, in your in your whether you can further explain and say for LDA in much more because around video is slightly difficult to understand.
I don't exactly remember any other specific. For PCA, you can check out the Andrew Ng's video, Andrew Ng's machine learning course. You can find out the PCA topic there, but LDA, I don't remember if LDA was there in Andrew Ng's course. LDA was not there, but you can search in the YouTube if some other in some other machine learning courses it is being taught.
Probably a couple of videos eventually we are not, at least I am not able to totally to the one that will run service model. That is the challenge.
Yeah, in YouTube there are many other videos on PC and LD and all other topics. So there you can find out. In Andrew Wenge's course, PCA topic is there, so you can check out that video. And LD, I don't exactly know whether there are any specific videos that are easier to follow like that. So you can search in the YouTube. There are many other machine learning courses of other universities. Is there any other questions or doubts?
Sir, I want to ask one thing.
Yes.
Actually, sir, my mathematics of ML is very weak. Could you please suggest me a book by which I can practice for that?
Book, I don't know any exact book for the mathematics of this machine learning, but basically you have to study probability, statistics, and calculus part a little bit. So any specific book, I don't exactly know if there are any specific books, but you can ask in the discussion forum. The instructor and the regular TAs would be able to answer your question if any specific book would be helpful for the mathematics.
Statistical learning is what it has been mentioned, and
Okay.
Programming Star is also following that one.
Yeah, elements of statistical learning. Yeah, that is a good book. If the mathematics related topics are there, you can study these topics from there. Yeah.
But challenge is following.
Could you please repeat which one?
It's elements of statistical learning. Trevor, Haskell, Robert,
Could you please write it in chat box?
Yeah, you can just Google search elements of statistical learning. So it is very popular book. Yeah, in the first result in the Google you will get it. Elements of statistical learning.
Oh, okay, sir. Okay, thank you. I understood.
Bhaskar Rao, are you asking something? Your voice is not clear at all. I'm not able to hear your voice properly. Can you write your query in the chat? Bhavik is asking, when we say LDA maximizes the projection of means with respect to the hyperplane, does that also mean geometrically when we visualize it in k dimensions, or just computational when we say projection? Yeah, so the LDA can also be used for reducing the number of dimensions in the data. So this projection is used, and LDA can also be used like that. So we can project the means of different classes on a hyperplane, and that way we can reduce the number of features. LDA is also used for that. So not just for computational, we can also visualize it and geometrically. So it is similar to PCA, how it reduces the number of dimensions. The methods are completely different, but it can also reduce the number of dimensions in the data. Bhaskar Rao is saying, for final exam only online lecture is sufficient, or need to refer to that I will not be able to answer. For final exam you can ask in the discussion forum. I think video lectures are sufficient, but the some of the books are also referred in the course, so you can follow those books also. But the instructor, where is the discussion forum? You can find out in the course web page. The discussion forum is there, so it's a Google group. So there the regular TAs and the instructor can answer your question. So if there are no other questions or queries, then we can end this session today. Thank you everyone.
Thank you.
We will meet
Thank
again
you.
next week.